Today our topic is about the pandas. See, the pandas is a core concept in the Python programming language. We all know that Python programming language is also known as the interpreted language. It is obtained from the ABC language. It was developed by the Gaida and Rossum in the year 1991. The Gaida and Rossum has given this language the Python programming as he was always liked to a famous TV show, Monty Python circus show. So for that sake, as he was very curious and he was a huge fan of that show, he had given this programming language the name as Python. Let's start with its introduction to the Pandas. The Pandas is an open source, highly popular Python package providing the high performance, easy to use data structures and data analysis workflows. The name originates from the term panel data, an econometric term for multi-dimensional structured datasets. An econometric term for multi-dimensional structured datasets. See, it is built directly over the foundations of NumPy. The Pandas allows user to elegantly clean, reshape, merge, filter, and extract complex relational or tabular data structures with minimal code overhead. So, we will be having out. See, where we have to use these Pandas. The Pandas is standard across all enterprise and research environments focused on data science. Primary domains includes the data wrangling and cleansing. It handles the structural discrepancies, filling or dropping missing values, NaN, and filtering out noise anomalies. Next to the time series and analytics or analysis. It is a specialized operation like window slices, data shifting, frequency, resamplings, and financial trending indices. The ETL pipelines. The ETL stands for the extract, transform, load. The ETL pipelines are the reading and ingestion workflows from databases, flat text documents, CSVs, and JSON. CSV stands for the comma separated values. The JSON spreadsheets or the Excel and converting them seamlessly into the memory. The statistical explorations, the rapid calculation of descriptive aggregates used heavily in business analytics setups. Next one, the introduction to the Pandas. See, we said before that the Pandas are having the series in the data frames. So it's about the Pandas series. A series is a one-dimensional array-like object which is capable of holding any data type like the integers, strings, floating point numbers, Python objects, etc. Unlike a basic NumPy array, a Pandas series maps each element to a dedicated user-defined label called an index. Think of it as a fixed-length ordered dictionary, mapping labels to values. Next one, the introduction to data frames. A data frame represents a two-dimensional tabular data structure with rows and columns, which is similar to an Excel spreadsheet or a SQL database table. It is essentially a collection of multiple aligned series objects which are sharing the same internal index map. The key concept rule, please note it down, it is very important. The series is a one-dimensional sequence containing explicit custom indices like a single column. The data frame, it is a two-dimensional table with dual axis layouts. The rows are considered as the axis 0 and the columns are considered as the axis 1. The core functions of the Pandas. The Pandas offer functions used primarily to ingest data or check foundational profiles. See, the Pandas is also having the alias name like just the NumPy. For NumPy, the alias name is of NP. For Pandas, the alias name is of PD. By using of as keyword, we will be providing this alias name. Instead of the using of the NumPy or the Pandas, we can simply import the Pandas by using the alias name PD. The PD.series, PD.dataframe, PD.read CSV, read Excel, concat, etc. etc. See, here's the PD.series, the data and the index. It constructs a one-dimensional structural labeled series. PD.dataframes. It initializes a 2D structured spreadsheet to the table. PD.read CSV. Direct passing workflow translating CSV files to usable data frame. Read Excel cross-platform structural file loading alternatives, concat, concatenate structural components along a specified axis. Essential Panda methods. There are methods and the functions which are evaluated directly or an instantiated series or data frame objects. We have provided you a table which consists of the method name and the function operations the purpose. You can clearly see the head tail previews the first or last and record entries quickly. Info prints memory details, schema, data types, and non-null element counts. Describe it. Compute standard summarizes the mean, standard deviation, min, max, quartiles. Next one, the fill NA. It is imputes or replaces empty or missing NaN items with safe placeholders. Drop duplicates. It purges redundant row structures from datasets automatically. Group by. It groups records across unique column metrics for structured aggregation. Next one, the crucial operations on the Pandas. It supports data transformation workflows through clean operations, selection and slicing, done using the column name or the coordinate systems via .loc, label-based index selectors, and .iloc, integer position index selectors, Boolean mask filtering. It is querying rows matching specific logic constraints. Example is given here. Axis operations performing computations column by column. Axis 0. Axis is of the axis 0. The axis operations which performs computations column by column or row by row. Next one, the example program on Panda series. The script shows how to create a custom series with labels, perform index classes, and calculate summary. States. See, you can clearly see here the program is provided by us. Next one, the example program on the Panda data frames. This program demonstrates the building a structure table from a dictionary, inspecting indices, running slices, and computing distributive sums. You can clearly see. Note it down. Series are the individual vertical fibers of data columns. Data frames are the interlaced fabric grids. Master filtering rows via Boolean indexing and slicing with .iloc to effectively unlock data analysis patterns. Okay, thank you. That's all for today.